Okay, let's unpack this. Um, Picture this. You're Sarah, right? Busy project manager, just trying to get a quick answer from the company chatbot.
Yeah.
You type, "Can you give me the sales numbers for Q1?" Pretty simple question, you'd think.
Seems straightforward.
But nope. Instead of data, you get some vague reply. Leaves you more confused. So annoying, isn't it?
Oh, it's incredibly frustrating. And, that scenario really pins down what we're diving into today. It's all about how well these really powerful AI systems actually get what you, the person asking, truly mean.
Exactly. So in this deep dive, we're really zeroing in on that exact thing, understanding user intent. How can we make these systems much better at figuring out what you really want? Because honestly, when they nail this, it makes such a huge difference.
It really does, getting you that quick, accurate information you actually need.
Right.
And our guide for this journey, so to speak, is a really interesting article by Marty Bradley over on Medium. He breaks down some uh, pretty crucial steps for making these AI knowledge systems smarter, basically, by boosting how they understand user intentions.
Okay, great. So let's get right to it then. Why is this intent thing so critical? I mean, can't the AI just look at the words I type and figure it out?
Well, it's a bit more complex than that. Just looking at the words is kind of like looking at the ingredients for a cake. You don't automatically know it's supposed to be a cake, right?
Ah, good point.
Accurately figuring out what a user intends to do or find out that's the secret sauce, really, it leads to much, much better, more useful responses. Because think about it, the same words can mean different things depending on the goal.
That's a really good way to put it. Like, if I say find the minutes, am I looking for the time or meeting notes? Very different.
Precisely. And getting that intent right, it has a big impact. The article mentions this study, I think it was Porky AI back in 2024. They found that when systems really understand, maybe even internally rephrase the user's query to clarify it, the response quality just shoots up.
Makes sense.
And what's also interesting, it can actually save computing power.
Yeah.
Fewer tokens needed when the question is clear from the start.
Right, less processing needed.
Exactly.
Yeah.
And for the listener, that means faster answers, less back and forth, more efficient all around.
Faster answers, less wasted effort.
Mm-hmm.
I like the sound of that. Okay, so how do we actually get these systems to understand what we mean? The article mentions some initial steps, tokenization and part of speech tagging. Sounds a bit technical.
It does sound technical, but we can break it down. Let's use that sentence again. Show me the latest financial report. Tokenization is basically just chopping that sentence into its smallest, meaningful bits.
So, like, show me the latest financial report, even the period.
Exactly. Think of them like individual Lego bricks or puzzle pieces.
Okay, separating the words. Got it. It's simple enough, right? But then comes part of speech tagging, or POS tagging. This is where the system tries to figure out the job each of those word pieces is doing in the sentence, grammatically speaking.
Ah, so it's role, like verb, noun, adjective, that sort of thing.
Precisely. It tags show as a verb in action, me as a pronoun, the as a determiner, a pointer word, latest and financial as adjectives describing words, and report as the noun, the thing.
Okay, so it's not just the words, but what they do. The article had that little bit of code showing the labels, like VB for verb, NN for noun.
Right, and here's why that matters to you, the user. By clearly spotting the action show and the main thing you're after, the financial report, the system gets a much clearer first idea of what you're asking.
Right, it's like labeling the puzzle pieces.
Exactly. It helps start putting the bigger picture together. This basic groundwork, this foundation, leads to much more accurate responses later on.
That makes a lot of sense. So, okay, the system has the words and their roles down. How does it then jump to the bigger picture, my actual intent behind asking? Good question. The next really key step is what's called intent detection and classification. This is all about figuring out your main goal. Are you trying to, say, get information? Or maybe update something or complete the specific task?
So going back to my find the minutes example, intent classification would try to sort out if I want the time that's maybe an information intent, or if I want to document, perhaps a data retrieval intent.
Exactly right. And the article points out that some newer techniques, like something called in-context learning, are really improving how accurately these systems can pinpoint your intent. They're getting much better at it.
And there was another code snippet for this too, wasn't there? Showing how you can train a model with examples.
Yes, it showed training with sample queries and their known intents.
Ah.
Things like, show me sales data maps to data request, update my email to account update.
Right.
Then when it sees a new query like, I want to see my sales figures, it correctly predicts, okay, this looks like another data request.
Ah, so it learns the patterns.
It learns the patterns, exactly. And the benefit for you, huge. Accurate intent detection means you're way more likely to get what you need fast. Less refreezing, less adding extra context. The system understands your goal right from the start.
That definitely sounds like a much smoother interaction. Okay, so words, roles, overall goal, check. What about the really specific details in my request? How does it grab those?
That takes us to the next layer, named entity recognition, or NERR. You can think of this as the system acting like a detective, pulling out the specific, important names and labels within your query.
Like what kind of names?
Things like company names, dates, places, product names, specific entities.
Okay, so if I ask what was Apple's revenue in 2024, NER would pick out Apple as the company
And label it organization, yeah.
and 2024 as the year.
Exactly. It would label that date. The article had a neat little Spilsky code example showing just that. Apple ORG 2024 date.
Right. And how does identifying those specific bits help me get a better answer?
Well, it ensures the system gets the specifics right. It's not just, oh, you want financial info. It's, you want financial info specifically for Apple and specifically for 2024.
Gotcha. Precision.
That precision lets it fetch a much more accurate, targeted answer. It zooms in on the crucial bits of your request.
Yeah, I can see how that level of detail avoids those annoying generic answers. Okay, but what about when I'm having more of a back and forth, like a conversation? How does it keep track?
Yes. That's where context handling is absolutely vital. It's all about the system remembering what we've already talked about. You wouldn't want to repeat yourself every single time, right?
Definitely not. Like the example in the piece, I ask, who is the CEO of Tesla? The bot answers. Then I ask, what about SpaceX?
Right. A good system needs to understand that what about connects back to the previous topic, the CEO, and that you're now asking about a different entity, SpaceX.
It needs to connect the dots.
Exactly. The article showed its sort of simplified logic for this. It holds on to the previous question, who is the CEO of Tesla? And the answer, Elon Musk. Then uses the context for the new question, what about SpaceX? To figure out you're still asking about the CEO role.
And the result is it correctly says Elon Musk is also the CEO of SpaceX.
Precisely. And for us, the users, what does that mean? A much smoother, more natural chat. It feels like a real conversation, not just isolated questions.
Less repeating, less frustration. Makes sense.
Definitely. It makes the whole interaction feel less robotic and more, well, helpful.
Okay, so we've covered understanding words, intent, details, and conversation flow. But how do we actually know if the system is doing a good job? How do we measure the quality?
That's a super important point. Continuous improvement relies on feedback. The article brings up evaluation metrics, and specifically this really interesting idea, using one LLM to basically judge the responses of another LLM.
Whoa, okay. An AI judging another AI? That sounds a bit sci-fi.
It does sound a bit like that, doesn't it? But it's actually becoming a really practical approach. It helps evaluate response quality consistently and crucially at scale. Imagine trying to manually check thousands of interactions.
Yeah, that wouldn't work.
So the article gives this example. You feed a judge LLM a prompt. Something like, okay, here's the question. What's the weather tomorrow in Miami? Evaluate these two responses.
Response A being specific, response B being vague.
Right. Response A, sunny, high of 75 degrees Aaron. Response B, Miami weather varies. Check an app. And the judge LLM would ideally come back saying, well, response A is better because it's direct, clear, relevant.
And the article mentions something called an ARISE evaluation dashboard. Sounds like a tool for this.
Exactly. It hints at the specialized tools being built to monitor, analyze, and manage the performance of these systems based on metrics like these. And the payoff for the user, confidence, knowing there's a process ensuring the system gives high-quality, reliable answers over time.
Trust in the system, that's key.
Absolutely.
Okay, let's bring it all back home. Let's revisit Sarah, our project manager from the start, the one getting frustrated.
Nice, Sarah.
How would her experience change if all these techniques, the intent understanding, NER, context evaluation, were working together properly?
Well, it would be night and day, really. When she asks, can you give me the sales numbers for Q1? The system, now much better at understanding her intent, wouldn't just stumble.
It wouldn't give that vague answer.
No. It would likely interpret her request much more precisely. Maybe even internally translate it something like action, retrieve data, data type, sales figures, time frame, Q1, current year. And it could then directly query the company's CRM or database for that specific information.
So she'd actually get the numbers. Huge win right there.
Massive improvement. But it could potentially go even further. By understanding the context, she's a project manager. She just asked for Q1 sales the system might anticipate her next likely need,
Like the what?
like maybe performance trends, or comparing Q1 to forecasts. So it could proactively offer, say, here are the Q1 sales numbers. Would you also like to see the comparison against the Q1 forecast, or perhaps the latest Q2 strategy presentation?
Wow. Okay, that's not just answering, that's anticipating. That's a real game changer.
Exactly. It turns a potentially frustrating dead-end interaction into something incredibly streamlined, productive, and genuinely helpful. It's leveraging all those steps, understanding the real meaning, the specifics, the context, and ensuring quality.
So I guess the big takeaway here, the core message, is that truly getting to grips with user intent, what someone really means, is absolutely fundamental for making these AI knowledge systems work well. It's not just about the words.
Not at all. It's about the underlying goal.
And nailing that leads to better accuracy, sure, but also more efficiency and just a much, much better experience for people like, well, like Sarah or any of us trying to get information.
Couldn't agree more. And, that brings up a final thought, maybe something for our listeners to chew on. If these systems get really good at understanding us, at anticipating our needs based on context and intent,
Yeah.
how might that change how you work,
Yeah.
how you find information day to day?
Yeah.
What kinds of interactions that feel clunky or frustrating now might become totally seamless even, proactive? And it really opens up some fascinating possibilities for the future, doesn't it?